Good day. Welcome to this talk on some of the new features and improvements that we've made in the front-end graphics over the last year. My name is James Lane. I'm a 3D graphics developer in the front-end team. In this talk, I'll introduce LabeledGraphicsBox, which can help better place labels around the graphics. I'll share on how we've improved anti-aliasing when rendering transparency for depth peeling. And I'm going to share on one of AxisObject's lesser known options, RangeBehavior. And I'll show an example of how visualized 3D view can be used to gain insight into what might be going wrong with the camera setup in 3D graphics. Oh no, my plot labels are being clipped. What's going on? That's crazy. Or what's happened to my tail rotation? It's not working. And why? How do I resize this so that I can resize these labels? These are just some of the problems that we encounter with some of our plot label and labeling mechanisms in the front end at the moment. And so we've introduced LabeledGraphicsBox to address some of these issues. So for instance, here's an example of LabeledGraphicsBox with the same plot from the previous example, but this time the plot label is being wrapped instead of clipped. And we can see that we can resize this nicely with graphic style selection and resize handles, and the label wraps depending on the size of the LabeledGraphicsBox. LabeledGraphicsBox gives us graphic style selection. So compared to an example with labeled, we can only select the graphics box itself. And then there's no control of what happens to the labels around it. And you can see space creeping in here between these labels on the left and the right. And this label just stays long where it should maybe wrap. But with LabeledGraphicsBox, when we select it, we get these graphic style selection handles. And they form around the whole construct of the LabeledGraphicsBox, the labels and the graphic. And with them, we can resize the LabeledGraphicsBox, and this controls the size of the graphic inside the LabeledGraphicsBox, as well as the size of the labels. So here we can, for instance, size it so that the labels wrap when they become too long for the width of the graphic, or we can extend it and the labels stay tight to the graphic throughout. Also, when we start this up, the tail rotation is still adhered to and still works. So LabeledGraphicsBox is a low-level grouping construct. It basically provides a box-level way of placing labels around a graphic or a 3D graphic attached to it. And as I said, the significant thing as well is that this has resize handles on it. So LabeledGraphicsBox has very specific sizing behaviors. The one thing that it's doing is it's trying to keep the labels tight around the graphic. So for instance here, if we change the size of the LabeledGraphicsBox, the label and the graphic are always pressed up against each other. As we change the size, the labels win the battle of who gets the most size. So for instance, as I shrink this, the label keeps its size and the graphic becomes smaller. As I size this down, at some point the label does size down as well, but it's the label. The way the sizing works is we give space to the labels first, and then the graphic fills up whatever's left behind. And one of the things that LabeledGraphicsBox attempts to do is to make sure that resizing doesn't jump and it stays smooth. So even as we shrink it, it stays smooth and we don't get jumping and erratic behavior. So setting the image size of a labeled graphics box will fill the space with the labels first, and then whatever size is left will be filled up with the graphic. So for instance, here, we forced the image size of the labeled graphics box to a fixed size. The label got constrained and filled up what space it needed, and then the graphic was placed in the remaining space. One thing, if we set the size of the labeled graphics box and then set a size of a graphics inside that, the inner graphic is constrained by the size of the labeled graphics box. So the labeled graphics box trumps that, and it controls the sizes. When you resize, what will happen is if you resize the labeled graphics box, the size of the image size option of the labeled graphics box is updated. If you select the graphics box and start to resize that, internally we adjust the calculations and adjust the options to ensure that this all stays smooth. So labeled graphics box works very much the same as the labeled function in terms of its options and usage. So here, for instance, some of the examples in the label documentation have a checkbox as a label, and labeled graphics box can have pretty much anything as a label. Here we've got a 3D graphic as a label, and it uses these similar placements to labeled. We, for instance, here asked for the label, the 3D graphics box to be placed in the top right corner of the labeled graphics box and the checkbox at the bottom. So that all works the same as labeled does. To control the distances between the graphics or the internal graphic or graphics 3D box, you can use spacings. So the spacings option will allow you to introduce space between the labels and the graphics. If you don't have that, the labels will stay tight to the graphics. Labeled graphics boxes can be nested. So here we've got a labeled graphics box with a labeled graphics box inside of that. And you can get all kinds of nesting behaviors. Labeled graphics box can be used as a label as itself. So in this example here, we've got labeled graphics with the labeled graphics box as the graphic. And then in this position, we've got the another labeled graphics box as a label for the outer labeled graphics box. Labeled graphics box also works in insets, and so on and so on. And you can use multiple levels have multiple nested levels of labeled graphics box. Moving on to some of the ways we've improved the front end in terms of it looking better, we've improved anti-aliasing for depth peeling. And what this means is basically if you're rendering transparency or you use the one layer method option, the edges of those should look smoother. So previously we use super sample anti-aliasing, and that's kind of capped at 4 samples per pixel. Whereas with multi-sample anti-aliasing, you can have 8 or 12 or 16 or 32 samples. So with multi-sample anti-aliasing, you should get smoother edges, and the edges shouldn't be as broken up and scratchy and glitchy. And so, yeah, less jaggies. So the reason that multi-sample anti-aliasing can be better is it's using more samples. So this depends on your hardware, but typically you can have 4, 8, 16, or 32 samples. But even if you only have 4 samples, it should still give a slightly better or smoother edges, because the samples or the subpixel samples are on using Poisson sample distribution, which gives good pixel area coverage, whereas super sample anti-aliasing basically is doing center sampling. So a disclaimer, if you're on a high resolution monitor and you only have a low multi-sample anti-aliasing sample count, the difference is less noticeable. But in low DPI monitors, it's more significant. But having said that, one of the nice things of multi-sample anti-aliasing is that this is actually faster. In tests that we did, we saw that it's typically faster, but it depends on the image size and the sample count. But so for instance, 4x4 or 4 samples for multi-sample anti-aliasing, which would be the equivalent of 2x2 super sample anti-aliasing, it's typically 20% faster. But as those samples get more, it's faster until you go above 1,000 pixels, though it's comparable in speed. And for 16 samples, it's similar as well. It's typically faster and negligibly slower. But the whole reason we implemented it wasn't so much for speed, but to make images look better. We've implemented this in our OpenGL renderer, and that's in 14.1. It came to our metal renderer in 14.2, and we've implemented it for DirectX, but we'd kind of like it to have more time to bake in the front end. So we'll maybe hold that off for the next release. I want to talk a little bit about a lesser known option of AxisObject called RangeBehavior. RangeBehavior allows you to control how an AxisObject influences the plot range and the image range of a graphic. So by default, the default behavior is automatic, and or you could think of it as range behavior going to plot range. By default, an AxisObject will influence the plot range, and it's the user coordinates of an AxisObject that contribute to the plot range. So for instance, in this example, we can just see that the user coordinates is 0, and that's contributed to the X plot range, and the dimensions or the length, the coordinates of this vertical AxisObject are influencing the Y plot range. So there might be cases where you want to have an AxisObject next to your graphic without affecting the plot range, and to do that, one can simply just say plot range behavior goes to image range. Or perhaps you want to have your AxisObject act like a normal primitive, like a line or an arrow, and where if it's outside the plot range, it must be completely clipped. And to do that, you can set range behavior to none. So these range behavior can be useful depending on how you want your AxisObjects to influence the plot range and the image range. Next, I'd like to show you one of the Wolfram language function repository functions we've been working on called Visualize 3D View. And this function is intended to help give you insight into the camera setup, the viewing options of your 3D graphics, and how they influence and contribute to what the final image is. So a recent example, we got an email, and we wanted to be able to see this parametric plot 3D, but the aim was that we would look at it from inside the box. So here we've adjusted the view vector so that the camera is inside the box, looking down to that lower left corner. But what we noticed was that once you started to interact with it, everything would get distorted and go all strange and funny. So what's going on? And we can use Visualize 3D View to gain insight into this. So I've used Visualize 3D View and just passed it my graphic 3D or plot. And here we get a display. The top is just the image we would see that would have been rendered from the 3D graphic. And these bottom two show the an illustration of the camera setup. So this red line is the view vector. It's centered inside the graphic. In the plot range here, we can see the helix or the spiral. That's the plot range. The camera viewpoint is inside that, looking out. We can see the lights down here at the bottom. And in this illustration here, we can see the view range. So the near clip plane is at 0.01, and the far clip plane is set to 1.49. But the interesting thing here is that this view angle is at 270 degrees. And what happens with automatic view angle is that it uses the box corners to try to decide how big the view angle should be. It tries to include all the box corners. And so that's obviously now being inside the box, they wrap around the viewpoint. And so it's given this unusual view angle. And let's see what happens when we now interact with this. As I drag it, we can see the distortion kicks in, and this view angle jumped to 180 and the view range collapsed. So that's weird. And I think this is just something internal that the front end, it might be a front end bug, but how can we solve this? So one way to get around this, you can see it has to do with the view angle. So let's just apply a fixed view angle. And now if we look at the visualization of this, as I start to rotate the graphic, it stays fine and it starts to rotate the box. And the view angle stays fixed, and we'll see the on the left here we can see the view vector actually turning around inside the box as we rotate. So visualize 3D view can be really useful to help you understand what might be going wrong with your 3D graphics and the various viewing options and why they're interplaying with each other in a strange way. One of the things just to say as well, I have extended this to orthographic projections as well, and that'll hopefully come soon. That's the end of my talk. It's gone quite quickly, so we can open up for Q&A. Why are you using row boxes? Okay, so raw boxes. So that refers to LabeledGraphicsBox. So LabeledGraphicsBox is as we said earlier, it is a LabeledGraphicsBox is a low-level or box-level grouping construct. So that's why I'm using raw boxes, because labeled is the functional form, and so for instance, if we evaluate this labeled and we go and look what it looks like in the box structure, you can see it's implemented it as a template box, and inside of that it's got a grid box. So that's how labeled has been implemented so far, but one implementation of labeled in the future might be LabeledGraphicsBox. So that whole thing could then change to just simply LabeledGraphicsBox inside. So that's why we were using raw boxes. Are there any more questions? Let's see on the chat. What is the head of the result of LabeledGraphicsBox? So if we just say head of this, that's a good question. Can I do that? Don't. It's raw boxes. So if I do, so yeah, so I think taking the head of it, it would just be LabeledGraphicsBox. If we did that, we got rid of the raw boxes. So we have to use the low-level constructs in our notebooks in 14.2. Yeah, so at the moment, LabeledGraphicsBox is still experimental. Ideally, the visualization teams will pick it up and they'll, so when its expressions are evaluated, they'll end up being typeset to LabeledGraphicsBox. So as I said before, this expression of labeled is a grid box, and then ultimately it will, but in the future, that might end up being typeset to what LabeledGraphicsBox gives you, just this. Yeah, so ideally you wouldn't use LabeledGraphicsBox raw. You wouldn't use raw boxes in that. But we'll ideally build this into labeled. And John Fultz did a great job of just saying how this is something we can build on in the front end that will make life better for labeling. So Jeff asks, will it export properly? Let's go and give that a try. So so like in a sense, if we pasted a LabeledGraphicsBox into a new notebook or that, it's just going to typeset back to this. So I'd imagine it does export properly. Are there any more questions? This talk went super quickly. Maybe I'll just say LabeledGraphicsBox. So it works like labeled. You can rotate your labels, and it uses basically all the options of labeled. So internally, we use rotation boxes to achieve the rotations. Yeah. Yay, a nice short talk. Cool. If there aren't any other questions, I think we can call that a talk.